Hello everyone, good morning, good afternoon, good evening. Today we'll be learning one important concept which every programmer should know and should abide by this principle. It is solid principle and it can be used with any programming language. Today we'll be taking JavaScript as a reference point, the code we'll be seeing, and we'll quickly understand what are the principle used for solid. So these are the five design principles which are used throughout the coding language. So these are the best standard to be followed. Okay. First, understand what are the full form of solid. So it is a five design principle which is used at the time of coding. S stand for single responsibility. O stand for open close principle. Mainly it is open for extension but closed to modification. Third one is Liskov substitution principle, interface segregation principle, dependency inversion principle. These are very, we'll understand it simply by seeing the code. So before that, let's understand why it is used. So it was, yeah, so Robert C introduced this principle in 2020 and it is widely used throughout the coding practice. So initially it was introduced for OOPS, object oriented programming language. Now as we know that coding evolved and we have functional as well. So this rule abide for functional component as well. So why solid principle are required? So this is because we keep our code clean according and maintain the code as per standard. It makes code easily maintainable and robust. So suppose you go in another team, you would want that the code should be clean, everything is organized, and you should know it by just reading the function name, what it does, what it doesn't. So let us understand this five design principle. It will be fast. So the first principle, which is the S of the solid principle, it is called single responsibility principle. It simply means that whatever functions, I'll be assuming that you are a programmer and or an aspiring one, but you have some idea of coding. Yeah. So whatever function you will create, it should do a single task. So we'll be taking JavaScript as a reference. So let us see this function name. It says validate and create task. We see over here the task one is validating. Some checks are done whether it is right or wrong, maybe received from the form. And in the end, some sign up or create task is done, right? So a function is holding two tasks. One is validating and one is creating task. So solid principle says this should not happen. So what you should do? You should create another function for creating task and call the method over here. So this is something wrong. Okay. So let us see the correct version of this code according to single responsibility. Now valid task. Firstly, see the name also say validate and create task. Two tasks are assigned in this function. This should not happen. So we have just written validate task. Now inside that one task is done, right? For the second task we have created a method and inside that method the logic for the create is written. So every function holds its own responsibility. This is the ideal first design principle, single responsibility principle. Every function holds its own functionality. We should not write more than one functionality in a single function. Suppose now we have to call a task over here, create another function like this and just invoke it, call it. So that is the part one. Now let us understand the second one. It is called open for extension but closed to modification, or it is also called open close. Okay. So this simply means whatever, see, in a code, not all code is written by you. It is written by some of your colleagues, some of the members, which is written, which were prior to you, who is not here. So the ideology is that whatever you write code, it should not impact the previous code. Let us see this example. Suppose I'll be using very basic example, but it is sufficient to understand. Suppose this data is fetched from database and it is having two roles at present. We know we create roles. One is admin role, one is user role. And this code is already written to check the role. If database, suppose this array holds this role, then return true, otherwise it's a falsy one. Okay. So if I'll do admin, it will give true because this database, this array holds this information, this role. Now if I am trying to add a validator role and it doesn't hold, so it will give false. Now what this open close principle says, it should be open for extension. Now suppose in future, now another role is to be onboarded, right? For example, validator. Then we should write code that should not impact previous code. Nothing should be deleted or modified. So let's see. The previous code, everything whatever we have seen here is same as it is. So we have written a logic to add a role. Okay, add role, and this is simply pushing the data into this array, or maybe some real database, then pushing the some code for appending the data, put task. But nothing is deleted. So we have extended now. So the current, when we write this add role validator, we know that our database is now having this admin, user, as well as validator. So this time if I'll try to check role validator, it will give true, otherwise false. Correct. So the idea is that we did not rewrite, we did not overwrite previous code. It exists as it is. We have added a new extension which can onboard new roles, validator, advanced operator, any role we want to add over here as per the application requirement. We can add, but nothing is removed. See, we haven't written any logic for removing admin or user. So that is the core part of this second rule, O of the solid. Open for extension but close to modification. We did not modify removed admin, we just added a new role. So now let us see the third rule. The name looks complex, but it's a simple rule. Liskov substitution principle. So the idea is, so if you are having a class, so in a code we see that lots of package we extend that package and write our code, right? The SDK we have. The idea is whatever class you are inheriting, whatever class we are inheriting, that we are writing inheriting code, then it is already inherited, but the function should be affecting the correctness of the program. Let us see an example for understanding it. Suppose we have a class bird, okay, and bird is having a method called fly. So something written with fly logic is written over here. Now here comes another bird. This is a specific bird, eagle. Eagle extends the bird. Now it's having its own dive method. So dive logic is written. So till now it is correct. So we have invoked a instance, eagle.fly, eagle.dive, everything is right. Okay. Now we know that penguin is also a bird, correct? But it's a non-flying bird, correct? So if we call over here, so as soon as we have extended bird, we have access to this fly method over here. But the problem is penguin cannot fly, so we should not ideally give the access of fly method to this guy penguin. So this is wrong. Extending wise, code wise, it will execute, nothing with the error, but logic wise it is not right, because penguin is not a flying bird, it's a swimming bird, right? So ideally it should not have access. So this Liskov principle says that whatever you should inherit, the principle states that object of superclass should be replaceable with objects of subclass without affecting the correctness of the program. Now, eagle has inherited fly because that's correct, it can fly, but penguin cannot fly. Let's see the correct version. We have a class, it's called bird. Now we have a method called lay egg. So whether it's a penguin, eagle, any bird, every bird lays egg, right? So we have this logic in a bird class. Now we have created two classes. One is flying bird, one is swimming bird. So flying bird is having fly method, swimming bird is having swim method. Okay. Now let's see. Now, so what difference do we have here? Now we have separation, right? So we have invoked eagle, class eagle extends flying bird, penguin extends swimming bird. Now eagle has access to fly and penguin has access to swim. We see that that check is maintained, right? So it is accessing correctly. Now penguin cannot fly because it doesn't have access. Eagle cannot swim because it doesn't have access to swimming. So this is the I of the solid principle. Sorry, L of the solid principle. Liskov substitution principle, also called LSV. Two more to go. The next one is, it's called interface segregation section, ISP. So in simple words, what is this principle? Whatever you do, you should not do based on chaining. Some checks should be there. Okay. For example, if suppose I am a vegetarian, I enter a restaurant which holds both for the veg and non-veg guys. Now, if someone will give me non-veg menu card, it doesn't help me, right? Because I'll not eat it. I should need the veg menu card. Now, according to this only, now think from program perspective. In the production level call application, lots of APIs, heavily used APIs are there. Okay. Now, some case APIs are not required at all. For example, let's think, suppose we are having this validator role. For validator role, some APIs are not required only. And we can check if role is validator, not invoke the APIs only. For admin, it should invoke because it is having more access. So let us see one simple example. Here's a user class. It's a constructor having username and password. And over here, initiate user given. Inside initiate user, validate user is invoked. And validate invoke something is written. The chaining of method is here, that's fine. But the problem is nowhere check is maintained. Okay, whether it is required or not required. Because every instance, if I am a suppose John is a admin, then it should happen. If John is not an admin, then it should not invoke validate user. So just an extra check flag is maintained over here, true false. You can do however you want, but some checks need to be done. Okay, so if this dot validate barabar equal to validate, if validate is there, then initiate user, otherwise not required. Otherwise no API call is required. So this is the fourth principle of the solid principle, which is ISP. Okay, interface segregation section. You can think like this example, that veg and non-veg example. So veg user doesn't need a non-veg menu card. So validator doesn't need any extra API call. Likewise. Okay, remove it. So 4 we have done dependency inversion principle. So this is the fifth principle and the last principle of the solid principle. So this simply means definition wise it is complex. If you are assigning, so what does this principle says? This principle simply means that whenever you are assigning some value, okay, to assign, do not hard code it or tightly couple it. So whenever we are getting some data, so instead of hard coding it, pass it to a function so that other thing can use it. It says data should not be tightly coupled. Suppose you are calling a constructor or you're invoking an API. That time, instead of hard coding the value, we should pass a reusable function, some function where data can be passed. So that if some other function is invoking, they can pass their data. Yeah, so that's all for this video. So let us quickly revise all the 5 again. So solid principles are used for maintaining the code readability. Single responsibility simply means every function is holding a single task. If you want to invoke, create a function, call it inside it. Open for extension but close for modification, the role one which we have seen. We have written a logic to add a function but need not require nothing for deletion, modifying. Liskov principle is that bird one, that penguin should not have fly access and eagle should not have swim access. We have created separation. Everything should be inherited based on the correctness of the logic idea of the program. Interface segregation principle is that veg non-veg one, the flag check. We need to do a flag check before doing it. Is it required? Then do it. Do the API calls, otherwise need not. Dependency injection means we should not tightly couple any variable. So whenever we assigning any value, that time we shouldn't hard code it. Instead, what we should do is call a function, reusable function, so that other can also access it. Solid principle are set of 5 design principles in object oriented or functional oriented programming intended to make software designs more usable, flexible and maintainable. Yeah, that's all for this video.